Hi guys, in this lesson we're going to be looking at some measures of central tendency, and my guess is we're going to have two videos because there's a lot of stuff in this lesson, so get ready to go. So our first thing is just what is a measure of central tendency, and it's a value that describes the middle or the center, right? The center, the middle of the data. So here we're still looking at data sets, but now we're looking at the stuff that describes the middle. Now there's different ways to find the middle. So let's look at those three to start with. So the first thing we're looking at is the mean. So the mean has a very special symbol to go with it, and you'll see several symbols as we go through this lesson. But mean has got this little symbol that looks kind of like that. It's called mu. It's a Greek letter. So mean is also known as the average. And we'll look at how to find that in just a minute. The next piece we're looking at is the median. And just like the median in the road, it's the very center or middle number. So one thing we have to do with this first to find the median before we can just pick the middle one is they have to be put in order. So our data must be in order. That's really important for finding the median. Okay, and so then the mode is the most repeated value. So now let's find those things for some of these data sets. So here's my first data set. So the first thing I always want to do when I'm looking at our data sets is put them in order from smallest to largest. So we're going to start with that. So I've got 35, and then I see I've got a 46, and then I see I've got two 51s, and then a 53, and then two 58s, and then a 59, and then a 60. So now that I've rearranged my data set from smallest to largest, now I can go ahead and find all of these different pieces. So when I'm finding the mean, I always add my values together. So I'm just going to put pluses in here so that we can see what we're doing. Right? So I would add all of my values, and then I divide by the number of values that I have. So in this case, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So I would add all of those values up together and divide them by 9. And when I do that, I end up with 52 and a third, so 0.3 repeating. So that's how we find the mean, or the average, is I add all of my data sets and I divide by how many data sets there are. So now let's look at the median. So remember, the median was when I put them in order, it's the one that's right in the middle. So it's not those, so it's not those, boom, boom. So there's the number that's directly in the middle, so that would be my median. So then mode, remember, is the value that comes up the most often. So I remember that I had two 51s and I had two 58s. So both of those values would be our mode. So I just write it as 51, 58, because both of those had more than one option. So now you have another data set down here at number 2 to look at by yourself. So the next thing we're looking at is the measures of variation. So we just looked at like kind of the main general numbers. So now we're going to look at variation. So remember, variation means kind of change or difference. So that's really what we're going to be looking here. So this measures of variation is a value. And we're going to look at several measures of variation that describes how spread out a set of data is. Okay. These can also be known as measures of dispersion. That's just something to know. You'll be really, this is kind of the big important thing, is knowing that these are our measures of variation. So we're going to be looking for the mean absolute deviation, or the MAD. So the MAD, or the mean, right? We talked that mean is average. Same idea here, but deviation tells me if I deviate from something, I go kind of away from the plan or away from the path. So let's put those together. So this is the average distance of each value to the mean. So this mean absolute deviation tells me how far away each value is from the mean. So again, you have to go back to the beginning and find the mean, and then you can find the rest of these pieces. So let's look at an example together. There's my mouse. So we're being asked here to find the mean absolute deviation. So the first step is I always have to find the mean. So in order to do that, I would add all of my values together, and then I would divide by 1, 2, 3, 4, 5, 6 to get the mean. So the mean, and I use my symbols, my mu. So the mean in this case was 79.83. And I'm going to erase that weird little dot there that I did. So that's my mean. So now to find my mean absolute deviation, I figure out how far away is each piece from the mean. So I would take my data point, which in this case would be 85, and subtract it from my mean. So how far away is this? So I end up with 5.17 for that piece, because it is 5.17 jumps away from my mean. This second piece, if I go ahead and look at it, is 5.83 away. So then I see that this next piece, my colors not being handy, is 8.17 away. So the thing I want you to notice here is that I'm just looking at the positive value. So you can subtract, just take the big number and then subtract the smaller number. Our negatives don't really come into play here. They will later. So right now you can just live in the positive land, okay? So that was 8.17. So this one is 0.17 away. And I just like doing mine in different colors. You don't have to do that, but it just makes it easier for me to follow. So when I subtract this, I get 12.17. And then when I look at this number 60, I end up with 19.83. So again, to find the mean, remember how when we found the original mean, we take all of our values, add them together, and then divide? We're going to do the same thing here. So now that I have all these values, these difference, or these deviations, I'm going to add them together and divide by how many there were. And in this case, there were 6. So when I do that, I end up with a mean absolute deviation of 8.56. So that tells me that on average, each data point is 8.56 points away from the mean value that we're looking at, the mean right in the middle. Okay, so we're kind of finding the mean of things twice. That's really what we're doing for the mean absolute deviation. So here's another example that I want you to go ahead and try, and I will definitely post the answers for you. Okay, so now we're going to look at some more of these different terms first and figure out what they mean. So here you see we're looking at variance, and variance has this little symbol as well, but it's this little symbol and squared, and that's really important. This is sigma, again another just Greek letter that we use to explain kind of our standard deviation and our variance together. But you'll just notice the difference there, that on standard deviation it's not squared and on variance it is, and that'll come into play a little bit. So the variance is the average squared difference of each value to the mean. So again, we're looking back to the mean, so you're going to be finding that a lot. So you'll see here that here's the big fancy way to write this formula, but we're going to look at it in kind of an actual just step-by-step process here in just a minute. Okay, and you can see how these two, the standard deviation and the variance, interact with each other. They're very similar, just one is squared. So what is standard deviation? So standard deviation is the square root of the variance. Well, that doesn't help us, but what we need to know is the standard deviation is the most useful measure of dispersion, or a measure of variation. We'll go ahead and call it our measure of variation. So it's the most useful, and we'll see why in just a minute. So what the heck do these numbers mean, right? That's always the question, is like, well, okay, great. What does it mean though? So if I have a lower standard deviation, right? So a smaller number means that my values in the data set are closer together. So that would indicate that a higher standard deviation, when I look at that, if my numbers are bigger, that my values in the data set are more spread out. Or farther apart from each other. Okay, so now let's look at one example, and then I'll show you how you can do this on your calculator as well. I'm pretty sure there's a way to do it in Desmos, and I'll have to look that up as well, but I know there's a way to do it. So here's our example. So find the variance and standard deviation for each data set. So the first thing we have to do is find the mean, or the average. So I would add all of my values together, and then I would divide by 5, because that's how many pieces of data I have. So my mean in this example is 92. So to find my standard deviation, I first want to find my variance. So my variance, right, remember it's that sigma squared, is I take my mean and my each data point and I find the difference. So I've got 85 minus 92. I square that. To that I add the next piece, squared, plus I take that third data point, square it, that fourth point, and my final, that's minus 92 squared. That's a minus in there. I'm going to go ahead and get my eraser out and make it look like it's supposed to. So I take every single data point that I have, subtract the mean or the average from it, and I square that. Well, then I'm not quite done, because I have to take that piece of information and divide it by how many pieces of data I have. So again, I have 5 here. So when I put this all into my calculator and go for that, I end up, with my variance of 29.2. Once I have that variance value, then I can take the square root of it to find my standard deviation. So my standard deviation in this case was 5.40. So when I took the square root of that variance that I found, that's what I end up with. Okay, so now there's some calculator steps. So if you have that TI, or when you get on campus and you want to try it using the calculator, go for it. So first thing you would do is you would hit stat and then enter. You would put your data values in your list. In the first list, it just makes it easier. Then you're going to hit stat again, and you're going to arrow over to calc. That just means we're calculating stuff. So then we choose our one variable statistics, which means we're just looking at one list. That's where this information comes from. And then you hit enter. And then once you do that, you'll get this whole list of stuff, and you'll be able to find your standard deviation and your variance just using your calculator. So I'm going to look at what we can do for Desmos and see if Desmos will do that without us having to type in everything that we're looking at. But even if we can't, we know that to find those values, the variance and the standard deviation, we just take our values, each individual value, and subtract the mean from it, and then square it, and then find the average of those. So now I want you to kind of practice these, the rest of these examples, and then in the next video we're really going to be looking at some distribution and go from there.